Hello everyone. Good morning, sir. I am Sudharshan. I am from Srinivas Ramanjan Institute of Technology, Anantapur. I am from Mechanical Department, second year. Today my topic is Torsion of Solids and Hollow Circular Shafts in the subject of Mechanics of Solids. First, we will define what is meant by torsion. The action of twisting or the state of being twisted, especially of one end of an object relative to the other. Torsional loads on circular shafts. Interested in stresses and strains of circular shafts subjected to twisting couples or torque S. Turbine exerts torque T on the shaft. Shaft transmits the torque to the generator. Generator creates an equal and opposite torque T. Net torque due to internal stresses. Net of the internal shearing stress is an internal torque equal and opposite to the applied torque. This is the formula for that. Although the net torque due to shearing stress is known, the distribution of the stresses is not. Distribution of shearing stresses is statically indeterminate, must consider shaft deformations. Unlike the normal stress due to axial loads, the distribution of shearing stresses due to torsional loads cannot be assumed uniformly. Axial shear components. Torque applied to shaft produces shearing stress on the faces perpendicular to the axis. Conditions of equilibrium require the existence of equal stresses on the faces of the two planes containing the axis of the shaft. The existence of an axial shear components is demonstrated by considering a shaft made up of axial salts. The salts slide with respect to each other when equal and opposite torques are applied to the ends of the shaft. Shaft deformations. From observation, the angular twist of the shaft is proportional to the applied torque and to the shaft length. Here, the angular twist is directly proportional to torque and shaft length also. When subjected to torsion, every cross section of a circular shaft remains plain and undistorted. Cross sections, toy, hollow, and solid shafts remain plain and undissociated because a circular shaft is axisymmetric. Cross section of non-axisymmetric shafts are when subjected to torsion. Shearing strain. Consider an interior section of the shaft has a torsional load is applied, an element on the interior cylinder deforms into a rhombus. Since the ends of the element remain planar, the shear strain is equal to angle of twist. It follows that this formula. Shear strain is proportional to twist and radius. Normal stresses. Element drives with faces parallel and perpendicular to shaft axis are subjected to shear stresses only. When normal stresses, shear stresses, or a combination of both may be found for the orientations. Consider an element of 45 degrees to the shaft axis, like here BBC diagram and ECB diagram. Here 45 degrees of angle. Element U is in pure shear. Element C is subjected to a tensile stress on two faces and compressive stresses on the other TWQ. Note all the stresses for elements and have the same magnitude. Torsional failure modes. Ductile materials generally fail in shear. Brittle materials are weaker in torsion than shear. When subjected to torsion, a ductile specimen breaks along a plane of maximum shear, that is a plane perpendicular to the shaft. When subjected to torsion, a brittle specimen breaks along planes perpendicular to the direction in which tension is a maximum, that is along surfaces at 45 degrees to the shaft. This is the sample problem. Shaft BC is a hollow with inner and outer diameter of 90 mm and 120 mm respectively. Shafts AB and CD are solid of diameter D. For the loading shown, determine the minimum and maximum shearing stress in shaft BCB. The required diameter of D of shafts AB and CD. If the allowable shearing stress in these shafts is 65 megapascals. This is the solution for that. After all calculations, next, angular twist in elastic range. Recall that the angular twist and maximum shearing strain are related. In the elastic range, the shearing strain and shear are related by Hooke's law. Equating the expressions for shearing strain and solving for the angular twist. If the torsional loading or shaft cross section changes along the length, the angular rotation of found has some of the segment. Statically indeterminate shaft. Given the shaft dimensions and the applied torque, we would like to find the torque reactions at A and B from a free body analysis of the shaft. TA plus TP minus 9 LB FT, which is not sufficient to find N torques. The problem is statically indeterminate. Divide the shaft into two components which must have compatible deformations. Substitute into the original equation. This is the sample problem for the two solid steel shafts are connected by gears, knowing that for each shaft, G equal to 11.2 into 10 power 1 psi, and the allowable shearing stress is 8 ksi. Deter, determine N, the largest torque TH that may be applied to the end of the shaft AB, and the corresponding angle through which end A on A of shaft B rotates. This is the solution for that. Design of transmission shafts. Principal transmission shaft performance specifications are power, speed. Determine torque applied to shaft at specified power and speed. Designer must select shaft material and cross section to meet performance specifications without exceeding allowable shearing stress. Find shaft cross section which will not exceed the maximum allowable shearing stress. Stress concentrations. The derivation of the torsion formula Tmax equal to Tc by J. Assumed a circular shaft with uniform cross section loaded through rigid end plates. The use of flange couplings, gears, and pulleys attached to shafts by keys in keyways and cross section discontinuous can cause stress concentrations. Experimental or numerically determined concentration factors are applied as Tmax equal to K Tcj. Next. Now we will come to the conclusion of for torsion. In conclusion, both solid and hollow circular shafts have unique characteristics under torsion. A solid shaft experiences shear stress that increases linearly from zero at the center to a maximum at the outer surface, making the core material underutilized. A hollow shaft is more efficient because it removes this inner material, making it lighter and more weight efficient for the same torsional strength compared to a solid shaft. The design choice depends on the application, with solid shafts suitable for high strength needs and hollow shafts for weight reduction. Thank you.